Good morning. Today I will be taking the data structure classes, and the topic will be tree. I've already in the previous lecture I have introduced with the textbook that is to be followed here is Introduction to Data Structure, and the author is Ashok and Kamthe, A.V. Aho, Hopcroft and Ullman, and algorithm in C++. And also you can use the Tenenbaum data structure using C and C++. It is a good book which is to be preferred here. And today's topic, as per the course outline, I will be taking on the topic trees. Now we will see what exactly tree is. Tree, introduction to, in case of introduction, while introducing about the tree, I will just explain what the tree is and what is the definition of the tree. Tree is a finite set of one or more nodes such that there is a special designated node called root, and remaining nodes are partitioned into disjoint sets T1, T2 and further up to Tn, means it can be any number of disjoint sets. A tree can have any number of nodes. As per it is shown in the example, a sample tree, that is this is a tree having 4 labels. Starting from A, this one is the root node, and B, C, D are the subtrees. Means you can say is the subtree, this one is the subtree, and this one is the subtree. So this is how the tree definition we can say here. Now, what are the terminology that we'll be using here for trees? Whenever we will be try to study tree, there are certain words, there are few of the words which is very important to understand about that words, because all the tree structure is related with these particular words. That means this tree terminology. And what are that terminologies are? Child, parent, siblings, degree. As you can see in the figure here itself, that edge, root, forest, subtree, depth, height, and further leaf node, label, internal nodes, and degree. Now we will come to explain you about what this exactly terminology holds here and what is the purpose of introducing this terminology. As per the tree terminology, parent node is, if you define the parent node, if n is the node in a T, that is tree, with left successor, because I have already shown in an example, that is previous tree diagram, A was a node and there was a subtrees which was adjusted either left side or right side, as per depending upon the number of nodes present into that. So that is what, when we are introducing here what exactly the parent node is. So if n is a node in T, that is tree, with the left successor S1 and right successor S2, then n is called father or parent of S1 and S2. So parent of S1 and S2 means S1 and S2 both are successor, or you can say it is a subtree, and it is connected with the edges to the root node of a tree T. S1 is called left child of the node and S2 is called the right child. It means this is how we used to introduce what exactly the subtree and right subtree are. Left subtree and right subtree. Left subtree, it is treated as a left child for the parent. For any of the parent node, whatever node which is residing below that particular node will be treated as a child node. Now, another term is siblings. Means how we are going to identify what sibling is. Again, if we go move into the previous here in the image, a sample tree, we can see here that at a label 2, B, C, D, this B, C, D nodes are treated as a sibling here. Again, whatever label we are considering, based on the label, we can say that these are the siblings. E, F, G, H, I, J will be the siblings. Again, at the last node, this will be the leaf node which will be introduced. Now, what will be the depth or height of a tree? Depth and height, two are the words frequently used for the same purpose, that is depth and height. whenever we consider depth and height, we have to always consider the root node, and the from node, which is the means you can say the terminal node, from where we have to count what is the height or what is the depth of the particular tree. The height or depth of the tree is maximum number of nodes in a branch. It is one more than the maximum level of the tree. Again, here comes the maximum level. That's why I was earlier explaining that based on the level, if the leaf node, we are considering any particular leaf node and we are trying to find out the depth or height of that leaf node, then we have to check that what are the edges that has been connected starting from leaf node to tree, that particular root node, and this will help you to find out the depth or height of the tree. We'll again come to explain what exactly and how it can be represented. Degree of an element. Degree of element here means what? Means we have to find out how many nodes are connected with a parent node, or you can say the in case of subtree, how many nodes are connected with that subtree. This is how we can find it out. If we take the example, previous example here in tree, see, if we want to find out what will be the that is degree of root node A, so we have to just check that how many edges are connected here with this root node. So B, C and D, these are the subtrees that has been connected. That means A has 3 degree. Similarly, in case of D, 1, 2, 3, we can count it out number of nodes connected with that particular root node, and we can state what is the degree of that particular node. Again, if you want to say degree of B, it will be 2. Similarly, for the leaf node, degree will be 0. The degree of a tree is the maximum degree of its nodes. Now, edge, path, leaf, branch. The edge is what? Means if you consider the parent node, root node, and the subtree, that is left subtree and right subtree. So in that case, when we are trying to identify what edge is, then just you have to check that what are the connected nodes from parent nodes or any of the subtree nodes. Path, you have to sequence of edges is called an path. Leaf, a terminal node in a tree, is called leaf node. Branch, path ending in a leaf is called branch. Means again, for finding out edge and for finding out depth or height, we have to consider this branch. That's why branch terminology has been introduced here. Branch is exactly what? It is a path ending in a leaf is called branch of the tree. Now it is further, it has been elaborated, the root node, the first node from where the tree originates is called root node. And in any tree, there must be only one root node. We can never have multiple root nodes in a tree data structure. This is a very common thing that is to be remembered here, that multiple node is not possible. Again, edge, I have already explained earlier in the earlier section that connecting link between any two nodes is called an edge. And in order to find out how many edges are there, we have to just check that how many nodes are present in that tree. And just by a formula n-1, we can identify how many number of edges are there. Similarly, in order to know the degree, we have to check the root node and how many edges are being bifurcated from that particular node. And level, in order to find out level, we can see here in the diagram, this one is the root node. This one is called, if you are line connecting A and B, this is edge. And if you want to find out level, the root node always starts with the 0 level. This root node always starts with 0 level. And this one, this will be the 1 level, this will be the 2, and this will be the 3. Means this tree having 3 levels. The level count starts from 0 and increment by 1 at each level step. This is what I have just now explained here. Height. In order to find the height, total number of edges that lines on the longest path from any leaf node to a particular node. Now, again, in order to find out what will be the height of the this tree, in this case, see here, if you want to find out the height of this D node at level 2, so we have to just follow this path from leaf node to the root node. If I want to find out this I, so this will give you the height of I. This is how we can derive height. Or and again, earlier I said that sometimes depth and level are interchangeably used, the term level and depth. Most of the time or frequently we used to find out height and depth in order to solve some certain kinds of problem related to the tree. So here level and depths both are interchangeably used here. And as per the definition, total number of edges from root node to a particular node is called as a depth. Earlier I shown here that this was the depth for D, node D. And what is the height of this tree? The maximum level means I at the leaf node. We just find it out what are the edges here. So this is how we can. Now we will understand what are the advantages of tree, why this has been introduced as a data structure in the data structure subject. The tree reflects structural relationship in the data. That means structural means what? How a parent node or subtree, a forest or a simple leaf, a single leaf is being connected or related with each other. That is the advantage of the tree. Means this is how we can maintain an hierarchy and understand at a different level what are the data present in that particular tree or that particular database. It can be understood very easily, and any of the problems, that is example of searching, sorting, or anything can be applied here. It is used to represent hierarchies. Hierarchy I have just now mentioned. Hierarchy why? Because parent node, child node, leaf node, this is what the relation. This is the hierarchy of the tree, and in order to maintain that hierarchy, we have given some certain terms, that is child node, right child node, leaf node, siblings, and this is how these are being connected with the tree. And that is why when we represent any data structure in hierarchy manner, it is very easy for anybody to understand and represent any of the data. It provides an efficient insertion and searching operation. That is also just now I explained here that why it is important, because searching and sorting, they are the two data structure operations that is to be always utilized in the data structure, because frequently these two, searching operation and deletion or insertion or sorting operations, are being done on the different data, because as per the need. Because as data get accumulated in a database, we need to find it out how many data are, what number of data are present over there. In order to find out any particular data, we have to apply a searching operation there, and possibly if new data comes there, in order to maintain that data, we have to either append that data at the last, or we have to insert that data in between of the database. So that is why efficiently all these operations to be performed on those tree. That's why this can be considered as an advantage of the tree, and this helps very easy efficiently this tree, because of hierarchy nature, it helps efficiently to insert or search any of the operations on that particular tree. Trees are flexible. It allows to move sub-trees around with a minimum effort, because it is very easy for any of the tree or sub-tree to move or interchange, or just to represent in a manner such that it can be hierarchically represented. And now this was the sample tree, and what exactly we have to study in this data structure is how we are going to represent the tree. In order to represent the tree, a tree can be represented in three forms, namely list representation, left child, right child sibling representation, degree 2 tree representation. These are the three representation of a tree. Degree 2 tree representation is exactly called binary tree. Now I will be introducing what binary tree is. The most common form of a tree maintained in a computer is a binary tree. This is the importance of a binary tree, and why the binary tree is considered here, because binary, as the name represent, binary means 2 represented with a 0 or 1. So in each case, in each tree, at most or at least 2 elements or 2 nodes will be there. A binary tree, how it is defined here, binary tree, now we will come to know. A binary tree is T is defined as a finite set of elements called nodes, such that either T is empty, called null tree or empty tree, or T contains a distinguished node, or called root of a tree T, and T remaining nodes of T form an order pair of disjoint sets for a tree T1 and T2. Means, as the definition earlier we saw that there were disjoint sets T1, T2 up to Tn. Similarly, a binary tree also can have disjoint sets of T1 and T2. Disjoint sets T1 and T2 here, because it is a binary tree. A root node will be there and 2 disjoint sets T1 and T2. 2 trees T1 and T2 are called respectively left subtree and right subtree, because it has been attached with a root node at the left side and the right side of the tree. In the previous diagram, we can see here that this one K, L, F, G, M, I and J. These are the leaf nodes exactly, because this has been attached in a tree, which has been explained here. Are the terminal nodes, we can say it with the word terminal node or leaf node. Now, what is the property of this binary tree? In case of binary tree, each node of a binary tree can have at most 2 children. Thus, at level R of a tree T, there can be at most 2 to the power R number of nodes. This is what we can, this is the formula, mathematical formula that can help to find out how many nodes are there in a tree at a particular level. Now, the number of nodes in a tree for a given number of levels in a tree, again, we are changing here formula based on the levels in a tree. The number of nodes in a tree for given number of level is 2 to the power n minus 1. Means it will be 1 less than the given number of nodes, because that is the root node, it has only 1 node, and rest of the nodes will be, in case of binary, there will be 2 subtree or 2 subnodes, that is left subnode and right subnode. What will be the depth? How we are going to find out depth for the tree with n nodes in a given, and this can be given with the help of formula dn is equal to, which has been explained here, that is this one. This one is the formula. 2 formula is given here. Dn is equal to log n base 2 plus 1. And dn is equivalent to log, means which is near about equivalent to log n base 2. Why base 2 has been considered here? Because it is a binary tree. And in case of computer, when you are representing binary tree, in case of computer, it always understands binary values only. This is the basic for the any of the computer which is being used here. There are different number representation also, that is octal, decimal and further, which can be represented. But this is the basic concept, and that whenever we want to represent here any mathematical concept, we always take base 2 as the, most of the time we take base 2. Now, definition of complete binary tree. What is complete binary tree? A binary tree T is said to be complete if all its level except possibly the last have maximum number of possible nodes, and if all the nodes at the last level appear as far left as possible, thus there is a unique complete tree T with exactly n nodes. This is what the definition explains here. And next is extended binary tree, that is 2 tree. A 2 tree is also considered as a binary tree here. Binary tree is said to be extended binary tree if each node n has either 0 or 2 children. In such a case, nodes with the 2 children are called internal nodes. As you can see here, the definition. And nodes with zero child are called external nodes. External and internal nodes are distinguished diagrammatically by using circles for internal nodes and squares for external nodes. Means in order to represent a binary tree, extended binary tree, we are using two symbols, that is circle and square bracket. Sorry, not a square bracket, but a rectangle we can say, or a square we can say. So for internal and external, both can be represented with a circle and square. Now, representing binary trees in memory, how it will be represented in memory, this is the important data structure here. Binary trees can be represented using linked list, or another way is using a single array called sequential representation of the tree. Sequential representation of binary tree represents use only a single linear array. Example is the root r of a t is stored in tree 1. This tree 1 here is an array has been represented here. If a node n occupies tree k, means if a node n occupies tree k, then its left child stored in tree 2 times of k, and right child will be stored in tree 2 times k plus 1. 2 times k plus 1 means left child and right child. So this is the formula which helps to represent the value in a tree or in an array. Just by evaluating these two formulas, we can place the values at left child and right child. Now, earlier was the array representation. Now, how it is represented with the help of linked list. So in linked list representation, tree is maintained in memory by means of 3 parallel arrays, that is info, left and right. This is the important part here for linked list representation data structure, and a pointer variable root. A pointer variable root is must or important, you can say, because this is the only root node which helps to identify the node, particular node, left node or right node, and the value or the data that has been stored into that particular tree. So each node n of t, that is tree, corresponds to a location k such that info k contains data at node n, and left k contains the location of left child and right k contains the location of right child. This is how your data is represented. I will show here with a diagrammatic also that how the linked list is being represented with the help of. This is the diagrammatic representation. This is how tree can be represented. This one is the root node. We are considering a root node, and this A is a node. We can say root node, which is pointing to the root node A, and B and C are the child nodes, that is left child and right child. And this one is the subtree. This one is the subtree which has been represented here, that is F, G, I, J, B, D, E, H. And this one are the left node, and this one is the right node for B subtree. Again, and this is pointing to the left node. This is pointing to the right node. Again, if a node don't have any left node or right node, then it will remain null, or you can say it will not point to any of the data. So in all the leaf nodes, you can see here it is pointing to the null value. So this is how we can represent. Another we will come to know that we can represent with the help of -1 also. The leaf node means further, because in leaf node there is no any bifurcation of childs there in that particular leaf node. Leaf nodes are the last or terminal node. That's why we point with the help of null pointer or with the help of -1. Now this is a graphic representation again here. A tree, how it is tree is represented. Tree root node is there, and what will be the relation? Parent node means root node which is pointing here, that this node will be the parent node, and rest will be the child nodes. This is how it can be represented. Now the very important data structure that is to be studied here in the tree data structure is traversing in a binary tree. This is how we can traverse, how we can move to the particular node up to the leaf node, and what procedure we are going to follow to traverse in a binary tree. So this is possible with the help of pre-order, in-order and post-order. These are the three methods. There are three standard way of traversing a binary tree. These standards are known as pre-order, in-order and post-order. And what exactly pre-order traversing process is? To process the root means we have to first read the root or process the root first, and after that traverse the left subtree, traverse the right subtree. That means in short we can say in case of pre-order, root, left node and right node. This one is root node, left node, right node. In case of in order, when we are trying to traversing the tree, what we will do here, we will traverse the left node first, then root node and then right node. Left node, root and right node. In case of post order, we will traverse the left node, right node, then root node. So this is how symbolically we can remember the pre-order, in-order, post-order, the three standard way of traversing the binary tree. And now we will come to learn what is the algorithm of this pre-order traversing. In case of pre-order traversing, we can see here that a pre-order method has been defined here with a 4 parameter, that is information, left, right and root. These 4 information will help to traverse in pre-order. And what is the procedure we are going to follow here? The algorithm traverse the tree in a pre-order. Step 1 we have to follow here. In case of step 1, we will set top is equal to -1. ये बताना है. Repeat step 3 to 5 while pointer is equal to null and apply process to the information pointer, right child. One example I will show here that how this pre-order, post-order has been traversing. This is a created tree from the given traversal. This is a pre-order, in-order, and with the help of pre-order and in-order, we can identify and create our tree. What will be the tree? How the tree can be represented? Only we have to remember the formula, that is standard way of traversing. That is pre-order. In case of problem, any data structure problem which is given here, that can be traversed with the help of pre-order and in-order. If it is given with the help of pre-order, we have to identify the root nodes, and with the in-order, we have to identify what will be the left subtree and right subtree. In case of this one, if you are considering pre-order, this will be the root node. And in case of in-order, we will see here that root node is in center. Now, in this case, this will be the left subtree and this will be the right subtree. So this is how we can create our tree. For example, this will be the root node, this will be the left subtree, this one will be the right subtree. And when again, in order to find out what will be the root of this left subtree, again we have to check the pre-order, that is A is coming here. That means A next, in case of A, this A will be the root node and left subtree will be the E, and C and K will be the right subtree. Again for H, D, B, G, here we have to check that which one is coming first. Means D. We can see here D is coming. That means D will be the root node and H, G, B. Now in case of in-order, we can identify from here that what will be the left subtree and right subtree. So H will be the left subtree and D, B, G will be the right subtree. And this is how, again for the bifurcation of this CK, we have to check that which one will be the root. So in this case, this is how we just identify the tree. And finally, we can see here that E, A, D, E, K, H, G, B, and C. This is the root. Finally, you will get the result. Means with the help of pre-order, in-order traversal, we can identify what is the route, what is the tree that can be created here, and how it has been traversed. Thank you. Again, I will be continue with the topic, which is important topic here, and I will let you know what exactly the tree is. Thank you.